graphs of three functions are shown on the diagram below. The scales on the axes are not labelled. The three functions are x maps onto cos 3x, x maps onto 2 cos 3x, x maps onto 3 cos 2x. Identify which function is which. Now, in a previous video, you saw that the number in front of this cos or sine function gives the range of the function. So this function here is 1 cos 3x. So the range of this function is from -1 to +1. Of the three functions, this function here has the smallest range. So we cos of 3x must be this graph here, this one with the solid dashed line, or the stronger dashed line. So we saw in a previous video that the range of a cos bx or a sine bx is from -a to +a. So if a is equal to 1, the range is from -1 to +1. So this function has the smallest range, so this value here must be -1 and this value here must be +1. If we look at the next function, its range is from -2 to +2. It doesn't matter about the coefficient of x. That has no effect on the range. It's just the number in front of the function that counts, this number here. So from the range we can actually identify these three functions. The range of this function is from -2 to +2. So the graph of 2 cos 3x is this one here. So this value here is -2, this value is +2. The function with the smallest range is actually called h of x. And the next one out, the second smallest range, is called g of x. So we can see that h of x, which we write here, is 1 cos 3x. Or you can read this as h such that x maps onto. This is can be just written h of x equals cos 3x. G of x is this one here, which we know is 2 cos 3x. And, well, there's only one function left, so f of x, the solid curve, is 3 cos 2x. So to identify these functions, we only had to look at the number in front of the cos function. We didn't have to look at the coefficient of x. In general, we could call that coefficient of x b. Now, the period of the function involves b. So we're going to label the x-axis of these graphs. Now let's look at cos of 3x. That's this function here, h of x. Let's look at the period of it. We saw in a previous video that the period of a cos bx, this is our general function, is given by 2 pi divided by b. So in this case it's 2 pi divided by 3. Now the period is the shortest interval over which the function repeats itself. So let's take the interval beginning at 0 and show the period of h of x. So we want this to repeat itself, so you can see what's happening here. I'm going to highlight one period or one cycle of h of x. Here it is. This is one period, and then we get the same pattern again and then again. So the period is the length of this interval. This is the shortest interval over which h of x repeats itself, and we know that the length of this interval has to be 2 pi over 3. That's what we got here. Now since the interval begins at 0, we add 2 pi over 3 onto 0. That means that this value here must be 2 pi over 3. So I'll indicate that. This value here is 2 pi over 3. Now let's take the period of g of x. What is g of x? It is 2 cos 3x. Again, the period only depends on b, this value. So it's 2 pi over 3. So its period is the same as the period of h of x. And you can see that on the diagram actually. Here's one cycle of g of x. So this interval has length 2 pi over 3. Now let's look at the period of f of x. F of x is 3 cos 2x, so the value of b has changed here. So the period is 2 pi over b, 2 pi over 2, that's pi. So the period of this function is different. So let's indicate one cycle of f of x. I'll do this in green. So here's one cycle or one period of f of x. And this distance here is the shortest distance over which f of x repeats itself. So the length of this green horizontal line is the period of f of x. And it's pi. So this value here is pi. Now let's label more values on the x-axis. Let's label where the graphs cut the x-axis. So how do we find this point here? Both g of x and h of x cross at this point. So at this point both g of x and h of x are 0. So if we put these functions equal to 0, we can find x. Okay, let's solve the equation g of x equals 0. We'll get the same values for the other function h of x. So we get the inverse cos of 0. Now in degrees that's actually 90 degrees. You can do that on your calculator. In radians that's pi over 2. So remember, pi radians is 180 degrees. So pi over 2 radians is 180 divided by 2, which is 90. So then x is 90 divided by 3, which is 30 degrees. Pi over 2 divided by 3 is pi over 2 times 3, or pi over 6. Now this is the smallest positive value of x that will solve this equation. Now there are other solutions, and we get them from going to the unit circle. But let's mark in the smallest positive solution of this equation. That's pi over 6. Now we can go and get this point straight away, because the distance between these 2 points is one period of either g of x or h of x. Both of these have the same period. So we add the period of g of x or h of x onto pi over 6. And the period is 2 pi over 3. So we can add 2 pi over 3 onto pi over 6. Well, 2 pi over 3 is the same as 4 pi over 6. So we have a common denominator of 6. So we just add 4 pi and pi to get 5 pi. So this point here is 5 pi over 6. Now, how do we find this point here? Well, of course, we could go to the unit circle and look for other solutions of cos 3x equals 0. I'll actually do that. I'll do this 2 ways. I'll use the graph to do the question and then also solve it here. 90 degrees is one solution for the inverse cos of 0. Now 270 degrees is the other solution. Now your calculator won't give you that, but I'll just quickly go back to the unit circle. We know that any point on the unit circle has coordinates cos theta, sine theta, where theta is measured anti-clockwise from the positive x-axis. Now we know that when theta is 90 degrees, we have a point whose coordinates are 0, 1. So as we've seen already, the cos of 90 degrees is 0. But here's the other angle which gives a point with x coordinate 0. The coordinates of this point here are 0, -1. And this value is the cos of this angle. But the angle corresponding to this point is 270 degrees. We measure anti-clockwise from the positive x-axis. So the cos of 270 is also 0. So here are 2 solutions. So 3x equals 90 or 3x equals 270. If 3x equals 270, it means that x equals 270 divided by 3, which is 90 degrees. So this is the next highest value of sorry, the next smallest value is 90 degrees. which is pi over 2 radians. So that's this value here. Okay, so that's one way we can get it, by getting other solutions of the equation cos 3x equals 0. However, we can also get it by the fact that this point here is midway between pi over 6 and 5 pi over 6. So we can see that from the curves. I'll just draw in the curve. This is one period of g of x, or we could have used one period of h of x. And it's a fact that the distance from here to here is equal to the distance of here to here. So the shape of this part is exactly the same as the shape of this part here. So we need the point midway between pi over 6 and 5 pi over 6. So we add pi over 6 onto 5 pi over 6. Well, that gives us 6 pi over 6 divided, and we divide by 2 to get the midpoint, to get the mean of these two values. These 6's cancel, so we end up with pi over 2. Now we can get these values by just adding on the periods, or the period of either g of x or h of x. So the period is 2 pi over 3, so we can just add 2 pi over 3 onto pi over 2 to get this value here. So I'm just adding 2 pi over 3 onto this. 2 pi over 3, remember, is the period of g of x or h of x. So here we have it. Get a common denominator of 6. 2 pi over 3 is the same as 4 pi over 6. Pi over 2 is the same as 3 pi over 6. Add the numerators. 4 pi plus 3 pi is 7 pi. So this here is 7 pi over 6. Actually, you can see that the distance between these points is 2 pi over 6. If I add 2 pi over 6 onto 5 pi over 6, I'll get 7 pi over 6. So if I add another 2 pi over 6 onto this point here is 9 pi over 6. Well, I can simplify that down a bit, although maybe it's sometimes good to keep the denominators the same. It's easier to read the thing, but I'll simplify it down. 9 pi over 6 is 3 pi over 2, divide above and below by 3. And now we add another another 2 pi over 6 onto this. So it's like 7 pi over 6 plus 4 pi over 6. That gives us 11 pi over 6 for this point here. It's 9 pi over 6 plus 2 pi over 6. Now let's look at f of x. Let's see where f of x crosses the x-axis. Well, we solved this equation. We have a product of things equaling 0, so that means that cos 2x must equal 0, or we can divide across by 3 to get cos 2x equals 0. 2x equals the inverse cos of 0 in degrees is 90 degrees. That means x is 45 degrees. So this value here in degrees is 45 degrees. Now we want this in radians. 90 degrees is pi over 2, so 45 degrees is half of pi over 2, which is pi over 4. Now let's get another solution. So let's get this value here. So we have the same setup as before. We want the inverse cos of 0. As we saw before, it's either 90 degrees or the next value up is 270 degrees. So x is either 90 divided by 2 or 270 divided by 2. If you divide 270 by 2, you get 135. Now this is actually 4 times 45 degrees. So this would be, or sorry, it's actually 3 times 45 degrees. So it's 3 times pi over 4 radians. So this value here is 3 pi over 4. Or it's 3/4 of pi, right? 3/4 of 180 degrees is 3 pi over 4 radians. Now these are the only values we need if we want to go and say get these two values. We just have to add on the period of f of x. The period of f of x, as we've seen already, is pi. Here's one cycle of it highlighted in green. So if we add pi onto each of these values, we'll be able to get this value and this value here. So to get this value here, we add pi onto pi over 4, because one period of the function runs from x equals pi over 4 to this value here. So if we add pi onto pi over 4, what do we get? pi over 4 plus pi. Well, we can write pi as 4 pi over 4. So that will give us 5 pi over 4. Finally, to get this value here, we can add pi onto 3 pi over 4. Well, that's 3 pi over 4 plus 4 pi over 4. 4 pi over 4 is just pi. Just getting the common denominator there, so that's going to give us 7 pi over 4. What about this point here? We've probably done more than we need to do, but this point here is got by adding pi onto pi. See, one period of f of x is pi, 0 to pi. Another period is pi plus pi. So this value here is 2 pi.